Okay? Now, oh man, yeah, that was a month and a half, and we just took care of it in like an hour and 10 minutes. Yeah, exactly. Now, because you're going over so fast now, since it's review, now there's a review of law of sines and law of cosines. And we're going to do them now, okay? And they work a little bit differently. I actually like the way they do it in this class a little bit better. So let's start by reviewing the law of sines. The one nice thing about this, yeah, you'll be able to use a calculator, and we're in degree mode, so we're good. But the idea, law of sines, okay, is, in 2H trig, they made you like find ABC and ABC. They made you find like everything in the triangle. In this, they're just gonna like put an X somewhere, and that's gonna kind of change. When we're just gonna find X, and that's gonna kind of change what the best system for approaching this is. So we're still gonna use the formulas, but this set of homework versus 2H trig set of homework, a slightly different system is useful. Okay. For law of sines, basically, you don't need to know what A, B, and C is. You just need to use them to know what the idea is. Think of the angles as like capital A and capital B, and the sides across them is the same, but lowercase letters. And the law of sines just says the sine of an angle over its opposite side is proportional to the sine of an angle over its opposite side. And you could also write equals sine C over C, but the thing is you're only going to have to set up one proportion in a problem ever, so that's enough. And then set up the proportion. Now, let me say one more thing. You need to have a surefire way of knowing when to use this versus law of cosines. So basically, when you can get the formula to work is when you want to use this. The really concrete way of explaining this is if you have two angles and a side, whether the side is between the two angles or not, it doesn't matter. You're going to use law of sines. Two angles and a side and two angles, same thing. So whenever you basically have two angles and a side given to you, you're going to use law of sines. Then use law of sines sometimes and law of cosines other times. So if the angle is not between the two sides, okay, and I always spell it ASS. Some teachers spell it like this to avoid like spelling a bad word. And I would prefer that you spell the bad word to remember that this is like the bad case. Angle side is called the ambiguous case, and it's a case where you get more than one possible answer, okay? But it's where you have angle side and you're solving for an angle. If you're solving for a side, we're going to use law of cosines. Okay, exactly. Okay, so these are the two cases. If we know two of the angles, we're pretty much going to go with law of sines. If we know two of the angles and a side, the angle's not between the sides and we're solving for an angle, we're going to use law of sines for that. And then this page will slowly go through each important case of law of sines. So here we go. The system I've defined is more than one system. Ormsby might go a different way than me. Using this system, every problem in the homework can be solved in one step, which is why I chose this system. If you use another system, you're going to have to like do law of sines, then do law of cosines on the same problem. Whereas this, yeah, which is very common, but based on the kind of questions being asked, if you use this system, you'll always be able to get it in one step, okay? There is, but it's not necessary. It's just would possibly be there for academic interest. In order to solve triangles, a law of sines and a law of cosines will solve every possible situation that could arise. There's no reason for it. It exists, and professors have it and like say, oh, and this is the law of tangents, and it's true. But it isn't. It doesn't have a utilitarian interest. It wouldn't allow us to solve for anything that the law of sines and cosines couldn't already do. Yeah. Yeah. Cool. So basically, the idea here is we want to set up sine 35 over 10, and then we want to solve for x. So I'd like to know this angle. So I subtract from 180. Exactly. So it's sine 45 over x. We could, but no need to. It's calculator. I would just say you don't want rounded answers. So I would say x sine 35 equals 10 sine 45, just leaving everything as an expression. And then I would divide by sine 35. I'm just cross multiplying, then dividing. And I just type this thing into my calculator. Good. Good job. So this is 12.328. Now I want you to notice a little double check here that's actually going to be helpful. Across from a 35-degree angle is 10. So wouldn't across from a 45 have to be larger? Yeah. And it is. Double check. And we're always going to make a double check, okay? Now here we go. Next. All right. Now we're looking for this x here. But we can't really set up law of sines, can we? Sine x over, no way to fill that in. Yeah. And so we can't really use it there. But if I just call this y, you got it. If I just call this y and solve for y, can't I just subtract from 180 to figure out what x is? Yeah. So sine of y over 12 equals sine of 24 over 7. I'm just going to multiply the 12 over, and I get sine of y equals 12 sine of 24 over 7. So 12 sine 24 over 7. That's equal to 0.697. Now, Andrew, didn't we just spend a whole page solving stuff like this? Where the sine equaled something? Did we just get one answer when we solved problems like this? No, we got two. In the ambiguous case, only when it spells ASS, basically when you're given two sides and the angle not between them, that's when you're going to have two answers to the problem, okay? Or possibly have two answers anyway, all right? So let's actually figure this out. Well, the two answers are going to be the top two, agreed? Sine is positive. So we've got to take the inverse sine, and I don't want a rounded answer, so I'm going to copy and paste the second answer. And then this is 44 degrees. I'm going to round to the nearest degree. 180 minus 44, which is 136. Well, let's be careful about this. So 44 and 136 is extremely common that one of these is extraneous. Okay? But here's how you test. Across from 24 is 7. So across from 7 is 24 degrees. Across from 12 is larger. So wouldn't the angles across from 12 have to be larger? Yes. Are both of these larger? That means they're okay. But if one of these angles was 10 degrees, you would have to cross it out because you have to have larger sides across from larger angles. So we're going to have to solve for two cases. X either equals 180 minus 36, or x equals 180 minus 44, since y is allowed to equal two different things. You're totally right. It's 180 minus, yeah, or just distribute the negative and just subtract both of them. Yeah, sorry, I don't know what I was thinking there. You have to subtract both angles to figure out what's left in the triangle. Good job. And those are the two possible answers for x. So I say ASS is a pain. So you'll kind of remember bad word, bad case. In terms of you have to worry about two answers. Now, isn't this ASS again? Because I've got two sides given, and then an angle that's not between the two sides given. Plus, I'm searching for an angle, which means I'm doing law of sines. So sine of x over 18 is equal to sine of 42 over 31. So I'll just multiply the 18 over. I have 18 sine of 42 all over 31. Point, yeah, 0.388 or 389, but we're not going to round. We're just going to do the inverse sine of the answer. That's 23 degrees, but there's two answers to a sine problem. Good job. Now let's check these answers. So let's put a 23 here. Let's put a 157. We've got to have, it doesn't. 42 is across from a bigger side. So 42 has to be the bigger angle. So the 157 doesn't work. Okay? So it's 23 degrees only. Now there's another way that I'd like to bring up of why 157 doesn't work, and this way works just as well. 42 plus 157 is over 180. Is that possible? That's another reason that you can tell. Exactly. Yeah, there's another angle. So you can't even have them equal 180. You've got to have it equal like less than 180 to have room for another angle. Yeah. Exactly. So yeah. Yeah. Yeah, and that doesn't work. So two ways of checking. You can totally. And so the thing is here is there's two ways to eliminate an answer, either by the rule that bigger sides have to be across from bigger angles, that'll eliminate bad answers, or there have to be 180 degrees in a triangle, that'll help you eliminate bad answers too. And there's some other trick that you can tell instantly, you know, but like I like that because that kind of makes geometric sense. Okay, we got another one, agreed? Yeah. Sine of x over 19 equals sine of 63 over 14 because it's ASS again, and we're looking for an angle, right? I'm going to multiply the 19 over. Okay. Sine equals 1.209, then we take the inverse sine, and we're going to get, why?
Because you can't have a sine bigger than 1.
No triangles have these measurements. It's impossible. Those measurements aren't possible measurements. And that's exactly the three ways that the ambiguous case works out with law of sines. Those are the three ways. Okay. And then that's the easy case of law of sines is the first one. So that's all the cases of law of sines. Now law of cosines. So here's how law of cosines works. So let's see. Basically, law of cosines is a generalization of the Pythagorean theorem. The Pythagorean theorem says c squared equals a squared plus b squared, but that's only when this is a right angle. So if this is not a right angle, we call it capital C, you have to take on another term, minus 2ab cosine c, capital C meaning the angle, and then it suddenly works. Well, you basically, like any problem, you need to know 3 out of 4 things, just like law of sines. You always need to know 3 out of 4 things, and then you're able to do it. So if you ever get confused, you know, you could just say, like, sine of 80 over x, and then sine of y over this. That's 2 variables. I don't know 3 out of 4 things. That's why law of sines doesn't work here. Agreed? So, well, basically, let's make a little list, though, Andrew, before we move on, of when law of sines applies. Basically, whenever law of cosines applies whenever law of sines doesn't. So that's going to be when you have side, angle, side, when you have 2 sides and the angle is between them. It's going to be side, 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 where you only know 3 sides. Or it's going to be ASS again, where instead of solving for an angle, you're finding a side. And those are the 3 cases. You don't know the triangle, because it turns out that even if you know two angles,
Oh, because it can be like they were shot.
exactly, like 60, 60, 60, that's all equilateral triangles.
So
Two on each side, like knowing all angles doesn't specify a triangle at all.
you could figure out the ratios.
You could. You're right. Which basically means you would just pick the value for one side and figure out the other side's relative to that. Cool. Yep, so knowing all angles isn't a case. All right, so the key is which one do you view as being C? Well, C is the only letter where you have to know the angle and the side, agreed? So, in this case, is x viewed as the C? So I'm going to do x squared equals 20 squared plus 10 squared minus 2 times 20 times 10 cosine 80.
Just put all that in.
Exactly. I mean, the whole thing. There's no point in doing that piecemeal. There's no variables in there. Either you're really bright, Andrew, today, or you remember like everything I taught you last year perfectly, even those little details. That's good. So 2 times 20 times 10 times cosine 80. 30. So x squared equals 430.540. So I need to take the square root of each side. I'll raise it to the 1/2 power and get that x is equal to 20.749. All right. Yeah, no, it's good. It's very good. Okay. Yeah, totally. Now here, law of signs wouldn't work because, like, we'd have two variables as angles, right? And you can't have two variables. You got to have one variable. So side, 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 therefore, is also law of cosines, please. Good. The C is always the one across from the angle in question. So 6 squared equals 8 squared plus 11 squared minus 2 times 8 times 11 cosine x. Yeah, and then I recommend simplifying this by finding like these three quantities and then solving from there. So 8 squared and 16 times 11 is 8 times 2 times 11. Well, let me just make a quick comment to make sure. You subtract the 185 over. You don't like combine the 185 and the 176. Agreed? Yeah. Okay. So they're not at all like terms. Yeah, one has a huge cosine on it. Yeah. Exactly. So you isolate it like this, and then we'll take the inverse cosine of that. Mm-hmm. Which is 32 degrees. Now, trig equations always have second answers, but with law of cosines, you don't get a second answer for the angle, and the reason is cosine splits like this. Can any triangle have an angle between 270 and 360? The other angle never works with law of cosines, so 32 is the answer. Okay? Good? Okay. Cool. So those are the two cases of law of cosines. Here's the third. You get all three of them. So this is angle side side. So why am I not using law of sines? Because I'm not solving for this. I'm solving for the side, right? So you view C is what's across from the 43 degrees. So 30.5 squared equals 18 squared plus x squared minus 2 times 18 times x cosine 43. Okay. Agreed?
Yeah.
Now, this is a quadratic. If I had a quadratic like 8 equals x squared plus 7x, wouldn't I need to put it in the form 0 equals squared term plus x term plus constant term? So that's exactly what I'm going to do with even with these hideous numbers. So I'm going to put 0 on this side. And the first thing I'm going to do is put the x squared term first, 1x squared. Then I'm going to put the x term, which is this monster right here. If I simplify that a bit, it looks like I have negative 16 cosine 43 is my coefficient on x. And then my constant term is even worse. It's 80 squared minus 30.5 squared. And that whole thing, whatever the heck that is my constant. So do you see kind of A, B, C for a quadratic?
Would it be 36?
It would. Thank you. And there's like my ABC of my quadratic. Obviously, this isn't the sort of thing that's going to factor. If I had to use the quadratic formula on this, I'd probably cry.
You could just solve it.
Nah. Using poly is going to be the best way to do this. So, because what poly does is if you plug in A, B, and C, it tells you what x is, right?
Yeah.
We're going to go to poly root finder. We're going to set the order of our polynomial to 2. And A is 1. B is negative 36 cosine of 43. And C is 18 squared minus 30.5 squared, which is negative 606.25. Got it in? Now you hit the solve button, which is just hitting the button under what they say is solve. Good. Now with ambiguous case, didn't we determine on the last page with ambiguous case it's possible to get 2 good answers? Oh, then just fraction to decimal. Yeah, just hit this back one to change it between a fraction and a decimal.
I didn't even know that.
Yeah, it just changes it from fraction form to decimal form.
I want to.
Well, no, yeah, because the second one's like more irrational. Now here we go. Totally. Now, I'm not going to do 3 examples again. On the last page, there's 3 ways ambiguous case can work out. Either you get 2 good answers, you get 1 good answer, or no good answers. So we saw that worked out with law of sines. Law of cosine, exactly the same way, but it's a lot easier to tell, because can't you just pretty much look at this and tell me what the bad answer is? Yeah. Bad answers are negatives or imaginary numbers. Good answers are positives. And you just, that's how you know which ones are the good ones and the bad ones. 0.084 only. Exactly. Not degrees, because it's a side length. And the other answer is bad, but it's possible to have 2 good answers. It's possible that both the answers are bad. All are possible. But we're not going to go through and do all the examples of that, because I think you can figure that out. Okay, we're just about done. So, the area of a triangle is 1/2 base times height. Do you agree? Mm-hmm. The problem is, in this case, 4 is not the height, is it? And figure out the height. So I know that the sine of 30 degrees is equal to height over 4.
Drop this down. 90.
You got it. But I mean, I'm solving it this way. There's other ways of doing it. But do you agree that the sine of 30 is h over 4? Which means that the height is 4 sine 30. But we know that the sine of pi over 6 is 1/2. So we solve for the height being 2. So I'm just saying sine 30 is h over 4, which means h is 4 sine 30.
So that's 4 times 1/2.
So it's 2. So the height's 2. Okay, now I can do 1/2 base times height. 1/2 6 times 2, which is 6. Okay. Okay, almost done because the last page is like Really easy. Except the problem is that's really hard in this case. You could solve it, but it's a nasty geometry problem to figure this one out because I don't know any angles. So what's better in this is to know something called Hero's formula. S times S minus A times S minus B times S minus C. Now S is half the perimeter, so it's half of all the sides added up. And obviously A, B, and C just represent the sides. So this is called Hero's formula. For this problem, S is 10 plus 9 plus 7 all over 2. Just 26 over 2 or 13. And then the area good. Exactly. You're just subtracting each of those. Well done. Now, that's if he wants a decimal. I will mention this, though. Sometimes this is a non-calculator problem, in which case you simplify the radical by breaking 4 down to 2 2's and breaking 6 down to a 2 and a 3. A 2 and a 3 out, so you end up with 6 root 26. And then, of course, yeah, if they accept a decimal, if it's a calculator problem, give a decimal. I just wanted to mention both. All right. Okay. Okay, last page. The next section is on identities, but on this section they just have a short preview of it, so very little going on here. They want you to remember that sine squared plus cosine squared equals, do you remember? No, it actually equals 1. Because, I'll give you a quick reason for that. On the unit circle, isn't the equation of a unit circle x squared plus y squared equals 1? Isn't that the equation of a circle? Yeah. And what's sine and cosine? X and y. So sine squared plus cosine squared equals 1. Okay, does that make sense? Now, there's 2 more they ask you to know, and I suggest not memorizing them, but knowing how to obtain them. Here's how. I'm going to divide every term in this equation by cosine squared. Now, Andrew, what's sine over cosine? Careful. Tangent. So sine squared over cosine squared is tangent squared. Cosine over itself is 1, and then 1 over cosine squared is? It is, and that's the other one. Now you obtain the last one by dividing the original equation instead of by cosine squared by? Exactly right. Sine squared over sine squared is? Cosine squared over sine squared is? Squared, yeah. And then 1 over sine squared is? You got it, nice. Okay, these 3 identities are the ones you're responsible for. And then being able to rearrange them to do what they want. Wow. So let's analyze 50. 50 says express cotangent in terms of sine. Well, I can't initially express cotangent in terms of sine, but I can express in terms of sine and cosine. What is cotangent in terms of both sine and cosine? Mm-hmm. That's it. But it says express this only in terms of sine, not in terms of cosine and sine. So well, hang on. So this equation is what connects sine to cosine. From this equation, can't I get that cosine squared is equal to 1 minus sine squared? And therefore, cosine is plus or minus the root of 1 minus sine squared? Okay, so that's how I do it. It's ugly, but this is how it works. So plus or minus square root of 1 minus sine squared all over sine. That is how you express cotangent in terms of sine only. All right. Okay? So use a combination of the ratios you know, and then this. Now it says express tangent squared in terms of secant squared. So yeah, there's a relationship between tangent, sine, and cosine, but isn't there a direct relation? Yeah, there's a direct relationship between tangent and secant. And so if we just rearrange that, can't we see the tangent squared is equivalent to secant squared minus 1? And I'll just use x's as opposed to, thetas, because they used x in the original problem. So being able to use the fractional identities plus these identities to express things in terms of other things, a couple easy problems in there. Okay? Make sense? Okay, well, that'll do it. That's everything.